We once we
On the eve of a very, very big rocket launch, satellite launch, and really a big day for the Weather Enterprise tomorrow as we launch our second of 4 weather satellites that NOAA is planning to launch in the upcoming years to kind of continue the GOES constellation and keep it going, help to give us reliable satellite data over the next couple of years, and improve our forecast and warnings. We've got a great expert tonight, satellite expert Jim Yo from NOAA joins us. We appreciate you coming on. Sorry for some of the tech difficulties we had at the start there, but glad we could get you on.
Hey, glad to be here.
And so we launched GOES-R, about a year and a half ago now. Give us just kind of your thoughts on where we've come since then.
Well, the launch of GOES-R was really exciting. I guess now I tend to think of it as GOES-16 now that's in a geo orbit and it's operational. We really have been impressed by what's occurred. That is, you have high hopes when you put new technology into space, and all the things, our expectations have come to fruition. We've really benefited from having the advanced baseline imager providing us greater detail with 4 times the resolution, 3 times as many spectral channels that help us identify features in the atmosphere and on the land and ocean surfaces better. And then finally having 5 times the scan rates, so that we're refreshing our imagery 5 times more quickly. All those things have really borne a lot of fruition. Even from the very early test phases, forecasters in the field and even out to the general public, people were really reacting positively to those, not just for the wow factor, but for the benefits they were able to provide in terms of making better forecasts, and that in turn enabling people to make even better out to the general public and better people were really reacting positively lives and to those, not just for the wow factor, but for the benefits they were able to provide in terms of making better
trial run when it was in its preliminary pre-operational test phase over the summer. But some of that data was used operationally in many forecast offices to kind of help warn. Give us some examples of where the GOES-R satellite has really just proven its worth over the past year.
I can give you a couple. One of the most significant ones in terms of lives saved, or at least lives moved out of harm's way, was when Hurricane Harvey made landfall near Corpus Christi. Of course, that was a huge system dumping a lot of rain and heavy winds on top of, of course, with the hurricane. We were able to track the motion of the eye so closely with using GOES-16 that FEMA was able to send people out during the eye passage in Corpus Christi and move people to safer locations before the back end of the storm hit, roughly about 200 people. So there's a very dramatic example. On the other end of the spectrum, there was an event in the fall where the airport in San Francisco was socked in by heavy fog. Big surprise, for San Francisco. But this did cause a closure of the airport. No flights could take off or land. The forecast was not favorable for that fog dissipating. However, using the imagery from the ABI with that rapid refresh and the fine detail, it was clear that the fog was dissipating more rapidly than forecast, and so that that closure was lifted earlier than expected. This allowed 32 planes to land on schedule that otherwise would have been diverted. The airlines say they saved about $100,000 in fuel. I don't know, if you're an air traveler, just the aggravation of being diverted, being one passenger on any one of those planes, let alone all the passengers on 32 of them, you think this is a huge thing in terms of keeping your plans intact, as well as avoiding other expenses being incurred.
And so now we're getting ready to launch GOES-S, which is going to cover the West Coast and the Pacific Ocean. With GOES-R and GOES-16, one of the things I noticed is that even on the western periphery, kind of that, the edge of the satellite view towards portions of Washington, when it was centered over the United States, we were still getting excellent imagery, even on the fringes. Is that just part of the higher resolution data?
Well, that's part of the nature of scanning from geostationary, and also having, as you say, the high resolution, very good pointing knowledge of the advanced baseline imager. A big deal, though, from my perspective, when we have this two-part constellation with GOES R, GOES S, or GOES 16, GOES 17, however you prefer to refer to them, is we'll have double coverage over most of the continental United States. So we'll be able to see our where we live with both of those satellites. But we'll be having coverage to the east as far as the west coast of Africa coming from GOES 16 or GOES East, as far west as New Zealand from GOES West. So it's the weather that we experience where we live doesn't originate where we are. As an example with hurricanes, of course, those originate as as waves off the west coast of Africa that deepen into tropical depressions and storms and hurricanes. And of course, a lot of the winter weather we see, not just on the west coast, but indeed coming across the entire U.S., is really originating out over the Pacific Ocean. And even though we think of GOES as being kind of the sentinel that gives us, that really enhances our short-term warnings and forecasts, we use it in our longer-term global numerical weather prediction models as well. We'll be looking at winds that are derived from the GOES West imagery and feeding those into our weather models, and that again will be impacting forecast well into the future. 3, 5, and 7 days for the continental U.S.
That's one of the things I always try to stress to our viewers. We're here in the Appalachian Mountain Range, and a lot of times we'll get that energy moving through the Pacific Ocean and coming ashore there towards portions of Washington State. And I stress there's not a whole lot of ground observation stations out in the middle of the Pacific Ocean. But with GOES now, it's going to be awesome to have that higher resolution data, more frequent data, be able to just show it visually, and some of the short waves and energy coming ashore.
No, absolutely. I mean, this is a big deal. And of course, in California, where they're looking at rainy season, the Pineapple Express storms that come from Hawaii and whatnot, and they're interested in those whether it's raining or not. They're because they've been experiencing a lot of drought and water shortages, so they're looking at that very closely. Another thing that happens in the western part of the U.S. is this the imagery we're getting now with the added channels allows us to spot and to detect wildfires more rapidly during the fire season. Actually, last year, in some cases, it was actually satellite forecasters who were spotting the onset of wildfires before local on-the-ground reports were being made. So this is helping get firefighters into respond to fires more rapidly before they became larger fires that required more resources to put out or contain.
Talk about the mesoscale sectors for a moment. I understand that once both satellites are operational, we're going to have 4 sectors, right? Are those going to be able to be moved around?
Yeah, that's absolutely the case. Each of the 2 GOES satellites will be able to scan 2 sectors simultaneously with 1 minute resolution. You can actually better that if, for example, from GOES 16 right now, you could target an area, the same area twice, but offset them by 30 seconds, so that effectively you achieve 30-second resolution for something that is evolving extremely rapidly. So again, you would be able to have 4 such sectors with 1 minute resolution when over the CONUS, for example, or in points beyond, with the full constellation in place, and that'll be really exciting. Certainly, in an active hurricane season, you can envision having more than one storm that you'd like to sample rapidly. One that's impacting the coast, and another that's developing. There's nothing that says you won't have a fire event or in the West Coast or something like that at the same time that you're having an East Coast hurricane. So we do have a protocol for to determine, when and where we'll do these rapid scans. I can envision there will be some competition for those from time to time. We even have one concern. I'm smiling because we talked about this today. We were hoping we could do rapid scans over Cape Canaveral from GOES R to support the GOES S launch, but there's some critical weather in the central United States, which I think has precluded that.
Sorry, Shay, you can't get a sector scan of your house for tomorrow.
Well, that does lead us to a question that we asked each other before the show. Is, going into the launch, looking at the weather in Florida, it looks like it could be a little bit windy down there tomorrow, maybe from the west southwest, or maybe a little bit of an offshore wind. Talk about the criteria for being able to launch on time at 5:02 p.m. What's the wind threshold and what's the weather threshold that would maybe stall or set it back on its time?
Well, let me give you the short answer. We look good in that regard. I had the good fortune of sitting on a panel with some folks who were more expert in the launch details than I am this afternoon. They told me that with our launch vehicle, we can really, and fully loaded like this, we can withstand low-level winds of up to 35 knots, and we're expecting winds that are no worse, no greater than 15 to 20 knots tomorrow at 5 p.m. and probably tapering off some after that. Of course, a bigger concern would be upper-level winds, and the wind shear that would be associated with them. But we're well south of the jet stream right now, so we don't anticipate any problem in that regard. So it looks like for tomorrow at least, the wind loading shouldn't be a factor for launch.
How much do NASA and NOAA kind of work together in the final days before a launch? How much is that partnership still going on even up to launch day?
Oh, it's very, very tightly. We're very much tightly linked at this point. Now, I wouldn't want to rule out, of course, the linkage with our private sector partners. With Lockheed Martin doing the launch, for example. Everyone is very focused on their own part of the mission and on the launch getting us there. But everyone is very concerned about what's going on in an integrated fashion as well. And of course, over the life of the program, the linkage is extremely tight.
Just thinking back to some of the first GOES rockets, we were talking about this earlier. Do you think when they launched the first GOES, they ever even envisioned what we have today?
I've often asked myself about that. I wonder what they really were thinking, that what they expected to get out of it. Sometimes I look back at some of the early images, not just from GOES, but from the first Tiro satellite in 1960. And, to someone who's watching weather broadcast on television today and seeing the imagery, you might look at it and say, boy, that was really unimpressive. But I'm sure to the people who were looking at that time, and then when I was a kid, I was looking at that, I was certainly impressed by it. So I think we've certainly met our expectations, but typically exceeded them, both in the quality of what we were able to produce in space, but also in how we've been able to apply it more and more successfully, both to research meteorology or environmental science, and ultimately, most importantly to me, to operational forecasting to support public safety and public decision making.
Gary, I think it was you and I were talking earlier, kind of saying, where do we go from here? What's the next step after GOES 16, 17, 18, 19? Give us your dream view, I guess, of what satellites could become.
I'm kind of like Jim was saying. I mean, I grew up in the same era he did when the first satellite pictures came down, and it's like, wow, that's pretty impressive. And then you look at today, but it's kind of like television sets. You think about TVs and how much they've improved, and you just can't imagine them improving anymore. And actually, Jim, that's what I wanted to ask you. Is there actually any difference between the GOES 16 and GOES 17? Are they identical satellites, or is there anything that's been tweaked out a little bit more with the 17 that you've learned with the 16?
Well, we fixed certain mistakes from the point of view of what we think of as a neutral atmosphere weather. We're really identical. The only thing is we've seen this promise fulfilled, or come to realization with GOES 16 and GOES East, and now we're going to see that expanded to cover the entire hemisphere when we get GOES 17 up. But there are lessons learned incorporated. The GOES R series does include 4 sensors for solar and space weather monitoring. So because space weather being a part of the NOAA mission as well, providing warnings and forecast of solar storms and the downstream effects in the Earth environment. One of those instruments is a magnetometer. The magnetometer itself is fine. The design of that, it met specification as built. One thing that happened on GOES 16 is apparently there's a source of magnetism that's too close to the magnetometer, so there's a lot of work trying to clean that up. Somebody said once, though, you can mill chaff, but you can't make wheat out of it, and it's the same thing. You can't make signal out of noise entirely. Well, but where the lessons learned have come into that is they've worked really hard in the integration of that magnetometer on GOES S that's going up tomorrow to avoid having any onboard sources of magnetism that affect that.
I'm glad you brought that up, because that was going to be one of my questions. With having 2 of these space weather sensors up now, what was the GOES 17 satellite going to be used for that GOES 16 wasn't going to be used for, I guess, in space weather monitoring?
Right. That's one place where that will come into play. But of course, having more, from the point of view of space weather, we're you're always trying to have coverage of the full, how do I say this? And not Earth-centered, but in sun-centered coordinates. Having 2 of them gives you a fuller view of the magnetic environment and the space environment around the Earth. So even if both were working perfectly, you'd get a better view. And of course, with having the magnetometer working better on GOES 17 is going to be an improvement for us.
This is kind of a random question, but I know NOAA does a lot of the space weather forecasting stuff, but does NASA do any of it as well? And if so, can NASA request to look at something specifically to NOAA?
Well, NASA does look at the data routinely. In fact, NASA has a very strong research component in space weather that's centered at Goddard Space Flight Center. Sorry, it's been a long day here, but a lot of interviews outside of Washington. NOAA has the operational space weather prediction requirement, and that's done by the Space Weather Prediction Center out in Boulder, Colorado.
Gotcha. Let's talk about the Pacific Ocean, that big, vast open ocean.
I'm for it, yeah.
Some of the advantages GOES is going to offer for maybe shipping or hurricane monitoring, even Hawaii, and just hanging out there in the middle of nowhere, quote unquote. They're going to be able to see a lot more things that are going to impact them.
Absolutely, and I can tell you that the Western and Pacific regions of the Weather Service have been a little jealous here for the last few months since GOES 16 became GOES East, and I think they're feeling a lot better served with the coming of GOES 17 to become GOES West out there. But you've hit on exactly all the points that are there. There's not over any of the oceans. There's really not sufficient coverage. Simply because you can't have ground-based radars out there providing the kind of coverage we have over the continental U.S. We don't have routine radiosonde launches except from a few islands that are very very sparse. So we really rely on satellite data and some ship reports and aircraft reports over the main air routes for the Pacific. And the Pacific is hugely important because it's the biggest, warmest ocean. You have we talk a lot about hurricanes impacting the East Coast, but of course, we need this coverage to cover typhoons in the Pacific Basin as well. Not just the ones that impact Hawaii and American Samoa and the West Coast, but of course, we have commercial interests that go across the entire Pacific Basin. Air traffic is a big deal, and of course, over the continental U.S. again, we have radars that tell us where thunderstorms are. One of the really neat things that's going to come with the GOES-R series is we'll not only have the finer imagery that shows us where thunderstorms are in much better detail in the imagery. You can see overshooting cloud tops, for example, that are indicative of really strong convection in the presence of thunderstorms. But in addition to that, you have the global lightning mapper that we haven't had a chance to talk about. The GLM is taking 500 frames per minute over it for both GOES 16 and eventually, of course, GOES 17, showing us exactly where the strongest thunderstorms are and collections of them. So we get a much better idea of where a system may be decaying, where it may be strengthening, where there's a likely outbreak for severe thunderstorms or even tornadoes, for example. This is a big deal for our Aviation Weather Center, which wants to route traffic, away from from those kinds of storms. Keep them away from the associated turbulence, so they have a much better idea of where that's going on. This is also a big opportunity for research meteorology, which I think will lead to better modeling in the future when we're able to look at that imagery and the overshooting tops, for example, in conjunction with the lightning maps. I think we'll be able to. We're going to learn a lot from that. That's going to play into the future of our severe storm weather forecasting.
I think the rest
To
of
follow.
Well,
Oh yeah. Sorry, Ricky. I'm just stumbling all over you. Follow up on the question about the Pacific. How is this going to help with ENSO monitoring and La Nina and El Nino conditions?
Well, one of the things we'll be able to do is we do have channels in the imager that are sensitive to variations in sea surface temperature. So, of course, that's a big factor for the southern oscillation. So we'll be using the GOES series for that. Of course, we combine those with the polar satellite data as well as with in situ measurements in order to do that monitoring and prediction. So I think we'll certainly have we should have more accurate and more detailed maps there. I don't know if it'll give us. I'm not really an expert in that, so it's hard to say for me to say how much lead time that'll give us more in prediction. But we'll certainly have better and clearer maps of that as it evolves.
Speaking of the Pacific, my question is overlap. So we have the GOES East. We also have the Himawari 8, Himawari 9. It goes west. Where is that going to fit in between? Is there going to be some overlap between the two? Maybe some enhanced products out of it? And also the other part is how far north will this go? Will it also cover the Arctic and some of the areas that we need some more studies on?
So it'll get us to the edge of the Arctic. We'll have very good coverage for Alaska, which is heavily dependent on satellite data. In fact, in Alaska, because it is at such high latitudes and the polar satellites come over so much more frequently there than they do over the mid latitudes in the continental United States. Frequently in Alaska, they kind of look at the polar satellites as fulfilling that sort of a role of being a constant watchdog in the sky that the rest of us look at or expect from GOES. But there's actually been a lot of excitement from at least earlier when GOES 16 was a little bit farther west from the Alaskan region. We really do extend far. Our coverage will extend as far north as Alaska, as far south as the tip of South America. And then I kind of almost forgot the first part of your question, Shay. So
I was asking about overlap with the GOES East satellite and Himawari 8 and 9 over on the Pacific side. So it looks like we're sort of getting the entire northern hemisphere covered.
Absolutely, and we do, of course, the northern hemisphere and extending to the southern. But what's really happening with Himawari is in GOES West is we're able to get that coverage around the equator, extending farther and farther west and more seamlessly, which I think again is really important for all of us. We already use Himawari data in our numerical weather prediction models because again they're upstream from us for a lot of our weather, particularly in the winter. And that was the imager on Himawari, of course, was basically a copy of the ABI, very similar in the construction, the channel selection, and the type of resolution we see from it. So that was has been a great opportunity for us to see before the launch of GOES 16 what we could expect from the ABI on the GOES R series.
Now, Jim, you hit on something about Shay. You were through, right?
Yes, sir.
I didn't want to step on you, man. Jim, you hit on exactly what I'm kind of looking forward to too. GOES 16 wasn't operational during severe weather season last year, and the lightning detection capabilities. Really looking forward to see what the system can do. How exactly does GOES 16? How is it able to actually detect lightning way down here on the surface of the Earth?
Okay, this is actually another type of imager that's making actually 500 images per second. It's able to detect and discriminate. It can detect both cloud to cloud and cloud to ground lightning strikes, which of course, both of which are occurring in severe weather, but via different mechanisms. I'm not particularly adept in the knowledge of the internal workings of the lightning detector. I'm a little bit more of on the user end of it, but but we're certainly very excited to have that because, again, as we say, when you're looking for thunderstorms, what we have been dependent on in the U.S., in the continental U.S., for the last 30 years, very successfully, has been with the weather radar network. Of course, now that doesn't help you over again offshore, but another place where you have problems with it is in the western United States, where the radar coverage is often cut off by mountainous terrain. So this is going to be a really big deal, I think, for looking at detecting and following the evolution of convective weather, severe weather, and thunderstorms in the western U.S., where we aren't able to rely on radars the same way as we are in the central plains and points east.
Yeah, and I wanted to jump in and talk about that. So I'm actually from the Four Corners area of New Mexico, and there's absolutely no radar up there. So it would drive me nuts looking for thunderstorms and looking for storms on the radar when it looks clear. We don't have the radar up there. So I think that this is going to be very good for that area, especially in other areas like that are just, missing that radar coverage.
Absolutely. I'd given another example of that in sort of an unexpected area, an area that's had been served well by radar, of course, was Puerto Rico until Hurricane Maria hit. And of course, the radar was knocked out. So at that point, having the GOES data, admittedly not as much the lightning data at that time, but the imagery, that became the only game in town. And that was really important, when there's nothing else. It was good. If you're going to have a substitute, have a really good one, and that's what we had for forecasting and monitoring in Puerto Rico when Hurricane Maria was impacting them.
Definitely.
I'd like to turn back for a minute back towards the launch and then the timeline going after that. With GOES-R, obviously we had a fairly lengthy checkout period, being a brand new satellite. It was checked out over, I think it was just about over the longitude that Memphis is in here, about 89 degrees west.
That's right.
Is the GOES-S, when it goes up, I guess the checkout period and so forth is going to be shorter, and will it go straight into orbit in the GOES-West position, or is it going to do a maneuver like GOES-East did?
It will do a maneuver like GOES-East. It will go into a central location for a checkout period of about 6 months, roughly. It takes about 17 days actually to achieve geostationary orbit. Tomorrow you'll get up to that's called the geotransfer position, which gets you almost there, and then you start doing a series of maneuvers with the onboard, thrusters that boost you up to the geostationary orbit. It's good to have it over the central U.S. when it starts, just because that allows you to do validation and checkout with all of your the systems at your disposal. It'll be very closely overlap with GOES-East, GOES-16, for example. It will be partially overlapping with the current GOES-West, which is GOES-15, but also with all the ground-based instrumentation and everything. This it does take a while to turn on the instruments, so they're not up and running, of course, from the moment the satellites is launched. So now, having said that, even though it will not be at its operational position until roughly 6 months after launch, the data will be available to forecasters for evaluation and comparison. And that, I can tell you that evaluation and comparison quickly turned into use. All these examples that we've talked about collectively with the GOES-16 are indicative of that. So somewhere in about 6 months after launch, it'll be allowed to drift, or actually encouraged to drift, so that it's about as far west as California, but centered over the equator. And at that point, it will become GOES-West.
That was going to be my question, was when kind of a rough estimate of how much time before we start getting non-operational data into the products.
Right. And certainly from the point of eye candy, at least, I think we can expect to start seeing some preliminary select images, from the ABI probably about 2 months after launch, sometime in May.
The countdown's already on.
It's exciting. That's I think.
So I guess, are you down there for the launch now?
I am. This is going to be my first satellite launch. I have mixed feelings about it. I've never been to one. Every satellite I cared about has gone up successfully, so I hope I'm not, like messing with a good track record and spoiling the mojo. But no, I feel a lot of confidence coming from the launch team, from the NASA people and the Lockheed folks. The weather reports are good. The launch vehicle has an excellent history, and we have a large launch window. So, as someone explained, if you've got between 5 p.m. and 7 p.m., if somebody strays into the restricted area offshore, you actually have time to get them out of there, without losing the whole opportunity. So, I'm feeling good. I think we're going to get this thing up tomorrow.
Good old wayward boat on Twitter is always the demise of a lot of things. I had the opportunity to be down there for excuse me, for GOES-R, and it was actually an emotional experience because you put so much trust and hope into this rocket that's going to carry this satellite up, and when it actually happened, it was a nice moment. Where do you get to watch from?
I'm actually going to be at the press center
Okay.
at Kennedy, just to keep doing some interviews with NASA TV, particularly one right after launch. So I don't get the prime viewing location. This is a work mission for me, not a paid vacation. But hey, I'm excited all the same.
Well,
and that's the thing. I mean, getting satellites into space, getting people into space, that's a complicated thing. I mean, NASA makes it look easy. Elon Musk makes it look easy. But I know, Jim, you're going to be on pins and needles tomorrow.
Oh, absolutely. And you don't have to be right on site to be on pins and needles. So with the GOES-R launch, I was watching on closed circuit TV from the satellite operations facility in Suitland, Maryland, and I was on pins and needles there. It was, even just with and I didn't think I would be. Driving in through the rain and sleet on that afternoon, and far away from sunny Florida. But we were all. You get in there and you're waiting for this, and you have a lot of your time and and energy. I mean, really a lot of your career invested in it, and you're looking forward to it making the remainder of your career, the work that you're going to do during your career, more meaningful and better. So yeah, it's big stakes, and we're excited, but that excitement has both the joyful part of it and also that the part that's just a little fretful.
Now, I got two questions real fast, guys, if you don't mind. Jim, what's the life expectancy on 16 and 17?
Yeah, these have a design life of basically 10 years with 5 years on orbit storage. Now, that's my experience with the satellites is that they tend to outlive their design life, so that's pretty conservative there. So we'll have actually the GOES. What's the next sequence in the RST?
T and U, yeah.
Yeah, I have to go through the
alphabet
like I'm back in grade school. It's I'm a numbers guy. What can I say? But the launch of GOES-T is planned for 2020. Now that doesn't mean it would become immediately operational. It would be put into that central location in an on-orbit storage, which accomplishes two things. That means it's ready to replace, presumably, GOES-R, being the older of the two, would be the one that would be taken out of service first. So those, you never really know how those things pan out. So it'd be there for very rapid replacement of either of the satellites that when one should fail or when one should just reach a point of aging where you feel it's more prudent to replace it. The other reason to put it in space, as I understand, is it's more economical to store a satellite in space on orbit than it is to store it, in a bay and try to keep it clean and all on Earth.
Yeah, that makes sense. And actually, I'm glad you mentioned T and U. Are there any plans to put any different instrumentation, make them better down the road?
T and U will have basically the same payloads. If we have lessons learned from S in addition to R, the magnetometer example I mentioned earlier being the biggest one I can think of so far. Certainly, modifications would be made into place, but these would be more, fixing problems or tweaking rather than radical redesigns. I know that the design phase for the GOES-R series actually began almost 20 years ago in 1999. I think the first metal was cut for sensors for the ABI starting in 2004. The first real satellite construction for GOES-R began about 2009 or 2010, and it was delivered 5 years after that. So there's a long lead time on all of these. So I guess pretty soon then you can say it's time for us to start thinking about what will be possible 20 years from now. What will our needs be? Because that should be the driver more. Before the technology, you say what's the mission you're trying to accomplish? What are the data and observations you need in order to accomplish those? And then you start thinking about what are the sensors I need, in any particular orbit in order to achieve that. So yeah, probably, that maybe that'll be one of the things I'll get to do here in my golden years, is to start looking towards, what are the requirements going to be, if not the solution for achieving them, but what are those requirements going to look like in 20 years?
Cool. Thank you.
I have a viewer question that came in from JP Calb asking, now that we're launching all these new ones, what's going to happen to like GOES 15 and 14? Where are those going to be placed?
Yeah, they're put into orbital storage as well. And what that means is that their sensors are turned off, but their lifeblood systems are kept on. Their brain stays on and their comm systems stay on, so we can monitor their health and safety and overall condition, and we can call them back into service, provided we have enough fuel to get them into the right position, so that they could become a backup. They could come in and fill if we were losing one of our primary operational ones. But again, we want to have our backups really be as capable. That is of the R series, ideally, as opposed to having ones from the old NOP series. We can use them. We've talked about sharing one of those and moving it into an orbit favored by the Air Force. We'd certainly be open to doing that as well. When they are almost out of fuel entirely, or when the sensors have degraded past the point of functioning, or maybe they're more likely their solar arrays and their batteries have degraded past functioning well. What you actually do with the geostationaries is you boost them into a slightly higher orbit, so they'll kind of be out of the geostationary place and just leave them up there indefinitely.
I heard one time that a lot of the old satellites get used for kind of Air Force missions or communications missions. Is that true, or they're kind of repurposed?
They are repurposed, and we've certainly lent or sent some to other countries. We in the past, I think GOES 12 was moved to provide better coverage for Brazil, for example.
Okay. We had a question too, if something doesn't launch tomorrow, the backup date, and which I understand is Friday, in case for a weather hold or something like that, right?
Right.
Okay. We're not hoping for that, but it's there.
No, we're not hoping for that. And I'm not sure what happens if we don't launch on Friday. I have to go home on Saturday.
Yeah.
So, the honeydew list gets longer and longer. She's not going to put up with my absence too long, no matter how exciting this is. But
that's for ULA and the range to decide, I guess. So.
Exactly.
All righty. Well, I'll open up the floor to any of the panel members. I think, Shay, do you have something? Or
actually, that was answered. Someone asked about what happens to the old satellites, and he says that they stay in storage, space storage. So I think I'll pass that on to Eric. Eric had something with COD.
Yeah, I just thought I'd kind of chime in with here at the end, because I'm sure a lot of people are wondering, okay, so where can I view all this great data that's coming down? One of my favorite places to view it is the College of DuPage weather viewer. You can go to weather.cod.edu and search for the satellite and radar there. They got a really, really nice viewing capabilities there, lots of zooms, and you can look at the meso data every minute when it comes in, change your channels and product descriptions, the whole thing really nice. But they announced today that they released a major update to that. And it includes things like adding your own mapping overlays, data overlays like watches and warnings, radar, surface data. You could toggle on and off the GLM lightning mapper data. Lots of really cool things in there. They create animated GIFs. So if you're looking for a place to go and actually view this data, you can check out the College of DuPage. Plug for them. Yeah, but definitely check it out. It's excellent. And the upgrade is great too.
Now I'm going to have to check that out. That sounds like fun.
All righty. Well, thank you so much, Jim, for joining us tonight. We hope everything goes smoothly tomorrow. You enjoy the launch and can actually enjoy it for when it goes up before you're bombarded by media. being one of those.
No, it's going to be fun. The whole thing will be fun, and this has been an absolute pleasure. It's been fun to talk to this panel with so much engagement and so many great questions.
Well, we're all excited and looking forward to it. I've got my alarm set to tune into NASA TV tomorrow, and we'll watch it all together. And James wanted me to mention that you can watch our coverage of the launch right here on our our Facebook channel. James will be taking care of that, and then you guys can watch it right here on our Facebook channel tomorrow.
Yeah, and while we're trading links, can I just point out the Twitter feed at NOAA Satellites? That's a good one, just not only for information about the launch, but about GOES-R and GOES-S and all of the NOAA satellites.
Sure, I'm sorry. We usually give our guests an opportunity to plug any social media outlets they want to. It's been a crazy day. I forgot to.
I just fought for it.
Hey, that's all right. It worked. So thanks again for joining us. We've got some great upcoming shows in the next couple of weeks as well. You can get information on that on our website or by staying tuned to our social media channels. And we will see everyone here next week for another edition of the Carolina Weather Group Weather Podcast. And we're clear.
That's a wrap. Awesome.
All right.
There's only one cargo ship designed to transport rockets for United Launch Alliance. And tonight, it's pulling into Port Canaveral with the robust flight hardware of an Atlas V.
We're a high-tech vessel, high maneuverability. We have to be because we get into some tight areas on shallow rivers. The Delta Mariner is unique. It has 2 aft Z drives coupled by computer with the bow thrusters that turns 360 degrees on demand.
This crew has work to do. In less than 4 weeks, the rocket must be safely delivered, inspected, and assembled in order to successfully launch NOAA's highly advanced GOES-S weather satellite.
I sense from the crew the pride being part of this mission. And when I put this vessel alongside the dock, it is a very accomplished feeling that we all have.
The arrival of the Mariner is the start of operations for the flow of a rocket.
Teams from ULA and NASA's Launch Services Program start by unchaining the Atlas V booster and Centaur components, wasting no time in developing a plan and getting organized for transport.
We're going to take the booster over to the ASOC. It's going to be Convoy 1 to be the leader, followed by the booster.
It's a very exciting day for the vehicle system engineers as we're offloading the launch vehicle that will carry the GOES-S satellite.
Here comes the Centaur second stage, with its pressurized stainless steel tank as thin as a dime. Unable to support its own weight until fully fueled, it's carried off the ship by a specialized trailer. Next comes the Atlas V booster, all 106 feet of it. This booster and 4 solid rocket motors have one job: provide enough energy at liftoff for the entire launch vehicle and payload to overcome the pull of Earth's gravity.
I never get tired of seeing the rockets come in. It's very exciting, especially on the Mariner.
Now on land, a challenging cross-base transport lies ahead to the Atlas Spaceflight Operations Center. Inside this multifunctional facility, crews will remove the protective coverings, inspect the hardware, and install the final flight components. For now, this mission remains a go, but the highly complex job of stacking the rocket is still to come.
From NASA's Kennedy Space Center in Florida, you're watching live coverage of the launch of NOAA's Geostationary Operational Environmental Satellite S, also known as GOES-S, second in the series of the nation's most advanced fleet of geostationary weather satellites. Hi, I'm Tori McClendon. Thanks for joining us. Today's launch of the United Launch Alliance Atlas V rocket is scheduled to lift off at 5:02 p.m. Eastern Time with a 2-hour launch window from Space Launch Complex 41. In just over 30 minutes from now, the Atlas V will send NOAA's newest geostationary satellite into orbit. Let's now go to Josh Finch and Mike Curie, who are standing by inside Atlas Launch Control for more information on today's launch. Josh and Mike, how are things looking so far?
Thank you, Tori. Mike and I are here in the Atlas Spaceflight Operations Center, also called the ASOC, which is on Cape Canaveral Air Force Station.
And the ASOC overlooks Space Launch Complex 41, where the Atlas V rocket is poised for liftoff at 5:02 p.m. Eastern Standard Time.
Inside of the ASOC, NASA Launch Manager Tim Dunn and United Launch Alliance Launch Director Tom Heater are working closely with the entire launch teams as we continue to count down to liftoff.
The launch teams began arriving on console this morning, and they've been working through launch procedures since then. The team received a weather briefing from the U.S. Air Force 45th Space Wing Launch Weather Officer Clay Flynn. The weather folks take a look at all kinds of constraints, luckily none of which we have to deal with today. They look at wind speed, cloud coverage, the potential for thunderstorms or lightning in the surrounding area, and even solar weather, which launch teams need to know before committing to launch. But as you see, we have a 90% go weather forecast with only a 10% probability of violating the launch constraint of cumulus clouds. Launch Weather Officer Clay Flynn is not concerned about that at this time. Winds are 20 to 25 knots from the west-southwest, temperature of 80 degrees, and we have a go forecast at this time for launch.
Right now, you're looking at a live view of the launch pad and the Atlas V and its 541 configuration. The Atlas V is a 2-stage rocket, and the number 541 indicates a couple of key features about the rocket that will power NOAA's GOES-S weather satellite into orbit.
The 5 indicates a 5-meter fairing. Inside that protective cover is where the weather satellite is safely tucked away for launch. The 4 indicates the number of solid rocket boosters attached to the rocket's core, and the 1 indicates a single-engine Centaur upper stage rocket. Thus, the 541, one of the most powerful rockets in the Atlas V fleet.
Yesterday, February 28th, the Atlas V rocket, along with NOAA's GOES-S weather satellite, was moved from the United Launch Alliance Vertical Integration Facility, or VIF, to the launch pad.
The Atlas V rocket segments make their way to the Cape over land and water. The large Atlas booster and the Centaur second stage arrive on a boat called the Mariner. The Atlas rocket booster, the upper stage called the Centaur, the solid rocket boosters and the satellite, already encapsulated inside the protective fairing, are built up vertically over a series of weeks. The rocket, fully mated, rolled on the mobile launch platform to the launch pad yesterday.
There's less than a mile between where the Atlas rocket is fully built up and where the pad will launch the rocket. Still, the roll takes about 30 minutes. Afterward, the rocket was secured into place and technicians fueled the Atlas booster with RP-1, a rocket-grade kerosene, and completed all service connections from the launch site to the rocket. These connections provide power, fuel, and more to the rocket and spacecraft prior to launch.
Today, the crew began the power-on sequence for both the GOES spacecraft and the Atlas V rocket. The crew is performing final preparations of the Atlas V power-on and electrical checks, including super-cold cryogenic propellants on board the Atlas V. Liquid oxygen goes into the oxidizer tanks of the first and second stages, and then liquid hydrogen into the fuel tank of the second stage Centaur. Final flight control tests will be performed along with final tests with the Eastern Range instrumentation, and then we will be ready for launch.
Right now, we are at T-minus 12 minutes, 12 seconds and counting. All fueling operations are underway. The Atlas V booster is being filled with liquid oxygen and RP-1, a rocket-grade kerosene. The fuel that will power the first stage's RD-180 engine, which produces more than 860,000 pounds of thrust. The Centaur upper stage also is being filled with liquid oxygen and liquid hydrogen. The Centaur upper stage is powered by a single Aerojet Rocketdyne RL-10 engine. The tanks are expected to reach flight levels at T-minus 5 minutes.
Things are progressing well toward liftoff at 5:02 p.m. We do have a 2-hour launch window should that become necessary for tonight's launch attempt. But at this time, we are not aware of working any technical issues, and weather is go. So there's lots going on, and while we follow the action here in Atlas Launch Control, we go back to Tori for more on NOAA's GOES-S mission. Tori?
Thanks, Mike. On today's broadcast, you will hear from program managers from NOAA and NASA to learn about the GOES-S spacecraft and how it fits into the GOES satellite system. You will hear more about the Atlas V rocket and its liftoff capability from United Launch Alliance. You will also hear from NASA's Launch Services Program representatives who will further explain why the ULA Atlas V rocket was selected for this spacecraft and also learn more about their mission, their role in this mission. NOAA's GOES-S satellite launching today is part of a 4-satellite program called the GOES-R series that includes GOES-R, now GOES-16, GOES-S, T, and U. GOES-S will be renamed GOES-17 once it reaches geostationary orbit. The GOES-R series is NOAA's latest and greatest in the GOES satellite system and will extend its operational availability through 2036. These highly sophisticated weather satellites will provide significantly enhanced weather forecasting capabilities across the Western Hemisphere. NASA Edge has spent a lot of time with the GOES team leading up to today's launch. Chris Gersh is on the set right now with Ed Grigsby, the GOES-R Deputy System Program Director from NASA's Goddard Space Flight Center. Chris?
Hey, thanks, Tori. Ed, hey, great to be back on the show here.
It's incredibly exciting, isn't it?
About 16 months ago, you were right here talking about GOES-R, which is now GOES-16, and now we're getting ready to set launch for the next satellite. How are you feeling right now?
Oh, this is amazing. This is amazing.
Now the satellite itself, I mean, has a lot of capability. Not only looking at the Earth, but looking at the Sun. Let's look at the Earth first. Tell us some of the capabilities of the satellite.
So this satellite, just like GOES-R, which is now GOES-16 on the East Coast, GOES-S is going to become GOES-17 on the West Coast. And just like that system, it has an ABI, the Advanced Baseline Imager, which is from previous generations 5 times greater, faster, right. 4 times the resolution, 3 times the spectral content. It provides high definition.
That's crazy. I mean, it's crazy. And the fact that, the GOES-S, or which will be GOES-17, will be covering from, the continental U.S. all the way to New Zealand.
It will. It will. The combination of 16 and 17 really completes the NOAA constellation for them for the East and West Coast, just like the GOES constellation always has. Right. And it's going to cover the African coast, all the way through New Zealand, even high latitudes that we've never seen before, Alaska.
And covering the sun.
And covering the sun. The solar platform covers the sun.
Now, when we were back at Goddard about a month or 2 ago, you told a great story how GOES saves lives. Could you share with the audience that story?
Oh, it's amazing. It really is amazing. So let's see. There are several good stories out there, but the best one that I recall is Hurricane Maria. When it hit landfall in Puerto Rico, it wiped out their radar. And GOES-16, even though we weren't operational, we're still in test mode, it actually took over for the radar and provided all the emergency managers with the information they needed.
That's incredible. And what are you expecting here in less than 20 minutes?
It's going to be amazing. It is going to be amazing.
Well, Ed, there's a lot of instruments. Now, looking at the sun, what are some of the key features of the satellite looking at the sun?
So we have SUVI, SICE, and EXIS, and we have a magnetometer, which covers the magnetosphere. Right. But SUVI takes pictures in several spectral regions of the sun itself and looks for coronal mass ejections. Right. Along with EXIS and SICE, they measure some of the heavy protons and ions that come from the sun. So we know that solar weather environment really well.
Well, Ed, I tell you what, this is an exciting time. Another great launch coming up for GOES-S,
yes,
and afterwards we have GOES-T.
GOES-T in 2020.
So we want you back here, in a couple of years, when we launch GOES-T, and we can't wait to interview you.
I am looking forward to it.
Hey, Tori, let's go take it back to you.
Thanks, Chris. As we mentioned earlier, NOAA's GOES-S satellite is part of the GOES-R series. NOAA manages the GOES-R series program through an integrated NOAA-NASA office that is co-located at NASA's Goddard Space Flight Center. This office oversees the acquisition of the program's ground system, while NASA oversees the acquisition of the spacecraft, its instruments, and the launch vehicle. Lockheed Martin Space of Colorado built the spacecraft and is responsible for its development, integration, and testing. Mission operations will be performed by NOAA at their satellite operations facility in Maryland. Harris Corporation of Florida provided the main instrument, called the Advanced Baseline Imager, and the ground system, which includes the antenna system for receiving data. United Launch Alliance of Colorado is the provider of the Atlas V launch service. NASA's Launch Services Program, based at Kennedy Space Center in Florida, manages the agency's efforts to commercially provide rockets for science missions such as NOAA's GOES-S, and also directs the overall launch effort, including overseeing development and integration of the rocket with the spacecraft. Let's now go back to Atlas Launch Control for an update on the count. Josh and Mike, how are things progressing over there?
Thank you, Tori. Things are still progressing to a 5:02 p.m. liftoff of the Atlas V with NOAA's GOES-S. From Atlas Launch Control, we're just a minute away from entering a hold in the count. This is a planned 15-minute hold at the T-4 mark. Although the T-clock stops, launch teams continue to work diligently toward liftoff. The T-clock is the official countdown clock and is stopped at that mark in the countdown and holds for 15 minutes. At the end of the hold, both the T- and L- clocks will be synced, and only 4 minutes will remain until launch.
While we were away, we got an update from Launch Weather Officer Clay Flynn that we now have a 100% GO weather forecast for GOES-S. They've removed the constraint for cumulus clouds, so we have nothing to worry about on weather at this time. Everything is green. Additionally, NASA Launch Manager Tim Dunn has briefed the team that upper-level winds are not a constraint for the opening of today's launch window at 5:02. So at this point, not working any technical issues. And weather is go. We're approaching our T-4 minute hold. This is a planned built-in 15-minute hold in 5, 4, 3, 2, 1. T-4 minutes and holding.
Seconds before liftoff of the United Launch Alliance Atlas V with NOAA's GOES-S spacecraft, the RD-180 engine ignites, supplied with fuel stored inside the large booster. The rocket gets extra power from the 4 solid rocket motors attached to the side at liftoff. In total, the rocket produces 2.25 million pounds of thrust.
Within 35 seconds of liftoff, the Atlas V will be traveling faster than the speed of sound. And within just 4 minutes, the rocket will weigh just a fraction of its original weight after it has jettisoned the solid rocket boosters, payload fairing, and the main Atlas booster. And just over 3.5 hours after liftoff, GOES-S will fly free above Earth.
Here's a detailed look at the full mission profile for today's launch of the Atlas V rocket.
The following profile details the important events of this mission using approximate times.
4, 3, 2, 1. And liftoff.
The Atlas V RD-180 main engine and 4 solid rocket boosters ignite to generate the 2.25 million pounds of thrust to lift the rocket away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 35 seconds. At 47 seconds, the vehicle experiences maximum dynamic pressure. All 4 solid rocket boosters, or SRBs, are jettisoned at 1 minute 50 seconds. 1 minute 40 seconds later, the payload fairing is jettisoned. Approaching booster engine cutoff, the Atlas V burns propellant at a rate of 1,856 pounds per second, traveling at over 13,340 miles per hour, and is located 83 miles in altitude and 267 miles downrange. Booster engine cutoff occurs 4 minutes 22 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The vehicle now weighs a little more than 5% of what it did at liftoff 4.5 minutes earlier. 10 seconds after booster separation, the first Centaur main engine start takes place. Cutoff of the Centaur main engine occurs just over 12 minutes after launch. The mission now enters a nearly 10.5-minute coast phase. At 22 minutes 38 seconds, the Centaur main engine is restarted. This burn will last 5.5 minutes. Following the second Centaur main engine cutoff at 28 minutes 9 seconds, the mission enters a 3-hour coast phase. Just over 3 hours 28 minutes after liftoff, the Centaur is started for a third and final burn. Approximately a minute and a half later, final cutoff of the Centaur main engine occurs. At 3 hours 32 minutes and 31 seconds, Centaur releases the GOES-S satellite for NOAA and NASA.
Inside of Atlas Launch Control, we are at T-minus 4 minutes and holding. We have about 11.5 minutes remaining before the terminal count to liftoff begins. About 15 minutes, 20 seconds from launch. And with that, we will go back to Tori. Tori?
Thanks, Mike. Kennedy's Marie Lewis had an opportunity to speak with Steve Voles, director of NOAA's Satellite and Information Service, about the newest addition to GOES-R satellite series.
Thank you. I'm here with Dr. Steve Volz, Director of NOAA's Satellite and Information Services. So, Doctor, tell us, if you could, how will today's launch impact our ability to observe and understand the planet?
Well, the GOES-17 launch, or GOES-S, soon to be GOES-17, is the second of a series of next-generation geostationary observing systems we're flying. GOES-16 launched about 14 months ago and has just revolutionized the way weather forecasters and the general public see environmental information. And it's hovering over the east coast of the United States, where it'll be in its permanent GOES-East position. GOES-17, or GOES-S, will be GOES-West, hovering over the west coast of the United States, providing that same kind of resolution, precision, and accuracy. And two of them together are just going to be a fantastic capability in orbit.
Yeah, absolutely. And now, in the last year and a half, NOAA has launched 3 next-generation satellites, including the GOES-S now. So can you talk about what this means in terms of our cooperation with other countries?
Sure. These satellites were decades, literally, in the building, in the design. We started in the mid-2000s for both series. So we're finally launching them, but it's a generational step in terms of capability on orbit. Our partners in space, the Japanese Met Agency, the European, the EUMETSAT organization, do similar steps, leap forward in technology. These put us back at the forefront in terms of meteorological capabilities from Earth orbit. We all share data, full, free, and open. We use their data in our models. They use our data. So we're all benefiting from this friendly competition to get the best observations from orbit.
And that data you're talking about really gives us such critical information to predict the weather and what's going to happen. So along those lines, what do you predict for the future of these satellites and the industry?
So this is, like I said, the first generational leap in capability for GEO in 20 plus years. So when you think about now the availability of information from satellites, from ground, from airplanes, from the whole Internet of Things, is going to allow a certain integration of information in a way that we can understand the Earth as a system much more holistically than ever before. It won't be just, here's a storm, here's a flood. It's seeing how they're all connected. So I think the next generation, the leaps will be in integration of all these great observing systems into a holistic view of how the Earth as an environment is working together.
All right, Doctor, thank you so much for your time. We'll send it back to you.
Today's mission is dedicated to 2 very special colleagues from United Launch Alliance and NASA's Launch Services Program, Gordon Meehan and Jean Forney. Gordon served our country in the United States Air Force, achieving the rank of Technical Sergeant. Gordon began his career as an electrical engineer at McDonnell Douglas, later working for both the Boeing Company and United Launch Alliance. United Launch Alliance dedicates this mission to their dear friend and colleague, Gordon Meehan. Gene worked in the Denver NASA resident office until his death last year at the age of 93. Gene served our country as an Army Air Corps pilot in World War II, completing 120 combat missions over Europe, and in the Cold War, helped put jet fighters on air carriers, along with training Navy and Marine pilots. When the space race started, Gene went to work for NASA, helping develop the Centaur cryogenic upper stage, a derivative of which is flying on today's mission. Gene served in multiple capacities throughout his NASA career, contributing to every Atlas mission since 1963. NASA's Launch Services Program dedicates this mission to their friend and teammate, and a true American hero, Gene Forney. As we mentioned earlier, GOES-S is the second satellite in NOAA's latest generation of geostationary operational environmental satellites, known as the GOES-R series. Let's take a look at the processing journey of NOAA's GOES-S spacecraft leading up to today's launch. We would like to welcome those of you just joining us on Facebook Live. Here at NASA's Kennedy Space Center in Florida, the ULA Atlas V rocket and NOAA's GOES-S spacecraft are poised to lift off at 5:02 p.m. Eastern from Space Launch Complex 41 at Cape Canaveral Air Force Station. Let's go now to Atlas Launch Control for an update. Mike and Josh?
Thank you, Tori, and welcome to those who are just joining our program for the live launch coverage of NOAA's GOES-S on an Atlas V rocket.
We have 8 minutes, 55 seconds before launch, and quickly let's get you up to speed. The Atlas V rocket on the launch pad at Space Launch Complex 41 is an Atlas V 541. It's one of the most powerful rockets in the Atlas fleet. It has a 5-meter fairing where the spacecraft is protected during ascent, 4 solid rocket motors providing extra lift to get the rocket and spacecraft off the ground, and a single-engine upper stage. The protective fairing also covers the Centaur second stage on this configuration of the rocket.
Right now, we are inside of a planned 15-minute hold in the launch countdown. The T-clock has paused, but the launch team continues to work through the final checks ahead of liftoff.
The Atlas booster and Centaur liquid oxygen tanks are at flight levels. Centaur liquid hydrogen is also at flight level.
The United Launch Alliance launch conductor, Ed Kidda, briefed the launch team ahead of the terminal count. Within the terminal count, should a condition exceed a launch constraint, teams are to notify by saying hold, hold, hold.
The launch conductor has verified with the range controller that solar radiation is also acceptable for launch. As we told you previously, weather is 100% go. No weather constraints at this time, and upper-level winds are also favorable. No technical issues are being worked at this time.
NOAA's GOES-S is on internal power. NASA launch manager Tim Dunn has polled his team. The Eastern Range has conducted its readiness polls. Launch conductor Ed Kidda has asked the NASA spacecraft coordinator to configure NOAA's GOES-S for launch, and launch director Tom Heater has conferred with mission managers for a go, no-go status. We're standing by for a final status check with all launch disciplines.
We're 7 minutes, 13 seconds away from launch. Launch conductor Ed Kidda will conduct a status check to continue the launch count and come out of our T-minus 4-minute hold.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion. Go. Pneumatics. Go. LO2. Go. LH2.
Go.
Has gas. Go. Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS. Go. Flight control.
Go.
GC cube. Go. COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count.
And as you heard, launch conductor Ed Kidda has received a go from all stations to continue the countdown. We're scheduled to release the hold in about 1 minute 45 seconds and count down to an on-time liftoff of the United Launch Alliance Atlas V rocket and NOAA's GOES-S spacecraft at 5:02 p.m. Eastern Standard Time.
L minus 5 minutes, 30 seconds.
Start list data capture.
Roger.
NSC, verify spacecraft on internal power.
Spacecraft is on internal power.
All steps complete prior to terminal count.
The GOES-S spacecraft configured for launch on internal power. Everything is go. 5 minutes away from launch. We have 45 seconds remaining in this hold. Plan to come out of the hold and launch at the opening of a 2-hour launch window at 5:02 p.m. Eastern Time. NASA Launch Manager Tim Dunn just reporting to Launch Director that NASA is go for launch as well.
On my mark, the time will be T minus 4 minutes and counting.
4, 3, 2, 1. And we are at T minus 4 minutes and counting.
After launch, we'll be hearing the voice of United Launch Alliance's Marty Malinowski providing a status of the flight of the Atlas V and NOAA's GOES-S.
At launch minus 2 minutes, the Atlas and Centaur power will be internal.
Ground pyros have been enabled. Liquid oxygen securing and liquid oxygen topping are underway. Atlas tanks will be pressurized to flight pressure at T minus 3 minutes. Shortly thereafter, the flight termination system will go internal.
Atlas tanks to flight pressure.
Securing LO2 topping.
250.
FTS internal.
Following Atlas and Centaur power to internal at T minus 2 minutes, the ground launch sequencer will command the launch sequencer to start at T minus 1 minute 55 seconds. T minus 2 minutes 14 seconds and counting.
$159.
Vehicle internal.
155.
Launch sequencer start.
And the Atlas and Centaur power is now internal.
Centaur LH2.
Securing Centaur LO2.
The flight termination system will be armed at T minus 1 minute 37 seconds.
7.
FTS armed.
We are 1 minute 30 seconds to launch.
The environmental control system will be reduced for launch at T-minus 1 minute 15 seconds.
1 minute 20 seconds.
OCU's armed.
FCS count started.
115.
Reduce ECS for launch. Roger.
110.
Vent valves locked.
The vent valves are closed on the Centaur, liquid oxygen and liquid hydrogen vent.
T-minus 1 minute.
Rock, report range status.
Range green.
Range Operations Controller reports range green. Everything is go. T-minus 51 seconds and counting.
T-minus 40 seconds.
Stable at step 3.
Closing in on 30 seconds before launch. 3 seconds before launch, the powerful RD-180 engine will ignite.
Roger.
25.
Status check. Go Atlas.
Go Centaur.
Go.
Everything is go. T-minus 15 seconds and counting.
9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Atlas has begun a pitch and yaw maneuver to steer to its planned path, an azimuth of 100.7 degrees.
At 35 seconds, the rocket carrying GOES will reach Mach 1, traveling faster than the speed of sound.
Down, right on schedule. Signatures look good. Roll program is complete. The speed chamber pressures are rolling off as expected.
At 47 seconds after launch, the vehicle will pass through the area of maximum dynamic pressure, or max Q.
Max Q.
This is the point when mechanical stress on the rocket reaches its peak because of the rocket's velocity and the resistance created by the Earth's atmosphere.
Booster has throttled up as expected.
You are also hearing the voice of United Launch Alliance flight commentator Marty Malinowski.
SRB chamber pressures continue to look good at plateaued.
At 1 minute 50 seconds into flight, the first 2 solid rocket boosters will be jettisoned, followed about a second and a half later by
burnout.
other boosters.
And we have indication of SRB burnout. Booster engine continues to perform well. Approximately 10 seconds to SRB jettison. And with indication of 4 solids jettisoning, looks like a clean separation.
And a clean separation being reported of the solid rocket boosters.
Vehicle
We are
has
2
begun
minutes,
closed
4 seconds into
steering.
flight.
The next major milestone, 3 minutes 30 seconds into flight, the payload fairing protecting GOES during its flight through the atmosphere will be jettisoned 3.5 minutes after launch.
Booster has throttled down as expected. Up on the RCS pyro valve activation. We have the RCS pyro valve activation at this point. The system is pressurizing to flight levels. Signatures look good.
Three minutes into the flight.
And booster has throttled back to 2.5 Gs. Preparation for payload for jettison.
Ten seconds away from payload fairing jettison.
Up on payload for jettison momentarily. And we have good payload fringe separation and CFLR jettison.
And we have a good payload fairing jettison, exposing GOES-S to space for the first time.
Signatures look good.
We are approaching 4 minutes into flight.
And booster has begun to throttle to 4.6 Gs in preparation for pico. Boost phase cooldown is underway. Logo pyro valve has been fired.
The call BECO stands for Booster Engine Cutoff. That will happen at 4 minutes 22 seconds into flight.
Boost phase chill down is complete. And we have pico. Shutdown looks good.
6 seconds after BECO, the Centaur second stage will separate from the Atlas booster.
The RL-10 engine. GN2 purge firing. The RCS is underway. We have ignition and full thrust on the RL-10.
And the Centaur single-engine RL-10C engine ignites for the first time. It produces 22,900 pounds of thrust.
Our steering has been enabled. Body rates look good.
This is about a 7.5 minute burn of the Centaur RL-10C engine.
Fixed angle, as expected.
Engine cutoff planned for about 7 minutes from now. This is the first of 3 burns of the Centaur main engine.
Continue to warm towards bottle temperatures. Signatures look good. Centaur PU has gone to closed loop control. Current range track shows Centaur making good headway down the middle of the corridor. Current altitude is 129 miles. Downrange distance is 701 miles. Current velocity 13,903 miles per hour.
Listening to the voice of United Launch Alliance flight commentator Marty Malinowski describing the flight of the Atlas and Centaur.
Shows basically a nominal booster. Beginning to see the RCS thermal conditioning firing. Signatures look good. RL-10 continues to perform well. Chamber pressures, lax pump discharge, and fuel venturi, all appropriate for the mark.
We're 7 minutes into the flight of GOES-S. Another 5 minutes remaining in this first burn of the Centaur single engine.
Small loss of data. As resumed, all signatures look good across the dropout. Current altitude is 146 miles. Downrange distance 1094. Current velocity is 14,685.
Eight minutes after liftoff, and everything continues to go well.
We have about 4 more minutes left in the burn of the Centaur main engine cuts off. That would be called MECO 1.
Oxidizer rich condition. DC, ox pump discharge, and fuel venturi all look good. Centaur tank pressures remain stable. Storage bottle pressures look good. Batteries are also good. Body rates controlling right down the middle. Track continues to show good progress down the middle of the corridor.
3 minutes remaining in this burn of the Centaur engine.
Centaur main engine burn continues to look very good. Chamber pressures, oxygen pump discharge, and fuel venturi all within expected parameters.
And we are 10 minutes into flight.
Hydrazine line temperatures have nearly achieved bottle outlet temperatures at this point. Continue to see light RCS firings. Still running slightly oxidizer rich at this point in the burn. A little less than 2 minutes remain in this burn. All systems look good. And Centaur is now commanding a nominal MR, having worked off the excess oxidizer error.
About 1 minute remaining in this burn of the Centaur main engine.
Centaur main engine continues to look good.
Standing by for the first of 3 burns of the Centaur main engine to Cutoff, also known as MECO 1.
Good. 4S settling motors on. CRDs have been safed.
And we have MECO.
Fuel tank pressures have been vented down.
About 12 and a half minutes into flight. We'll be in a coast phase for about the next 10 minutes prior to relighting the Centaur second stage engine for the second of 3 times today.
Centaur has continued its turn to MES 2 attitude.
From Atlas Launch Control, I'm here with Scott Messer, United Launch Alliance Program Manager. Scott, thank you for coming.
Thank you.
Yes, sir. And tell us a little bit how this launch is going so far.
Well, so far it is going almost perfectly. The count was very quiet today. In fact, probably the quietest count that I've been through. Actually, from a personal note, the only real big excitement for me was the birth of my fourth grandson this afternoon at T-minus 3 hours and 30 minutes.
Well, congratulations.
Yeah, so that's exciting for me. But the count was very quiet, and so far met all the milestones. Everything is looking good.
And so far for this year for United Launch Alliance, this is your third launch in 2018.
It is our third launch, and it's a great year. It's a big, busy year for NASA, and we've got a lot of interesting missions working with NASA. The GOES mission, of course, is our third mission this year, as you said, and we've at United Launch Alliance actually launched every GOES mission that has ever launched since 1975. So it's very exciting. We're in the middle of a 3-minute the first coast now. We'll go into a 5-minute burn after that, and then we'll go into a 3-hour coast where we put GOES into the geostationary transfer orbit. Some fun facts. As we finish this second burn, the vehicle will be traveling about 22,000 miles per hour. To put that in perspective, that would be about 7.5 minutes coast to coast from LA to New York. So it's moving pretty quickly. And at liftoff, the vehicle weighed about 1.2 million pounds. We have about 2.25 million pounds of thrust that gets the vehicle going. And as I said, we're excited to be part of the GOES mission. It's a great mission for the nation, and helps a lot of people with improved weather predictions.
And so after GOES is in its orbit, what's next for United Launch Alliance?
So as I mentioned, we've got a very busy year with NASA. Coming up in May, we've got the InSight mission, which will be the first Mars mission to ever launch from the West Coast. So that's an exciting activity, followed on in July 31st with Parker Solar Probe mission that will touch the sun, and then finally we'll end out our year with NASA with our last and final Delta II mission, the ISAT mission out of Vandenberg in September. So it's a busy year for us and a lot of excitement coming up.
Well, thank you very much for joining us today, and congratulations on launch so far, and also your other news.
Yes,
good to
thank
hear.
you very much.
Yes, sir. Thank you for being with us.
All right, thank you.
Centaur has achieved a 60% 4S duty cycle at this point. Signatures look good.
"19 minutes, 22 seconds into the flight of GOES-S. Everything continues to go well as the Centaur upper stage ferries GOES-S to its final destination in space, standing by for the second stage engine restart at a mission elapsed time of 22 minutes 38 seconds. So about 3 minutes from now.
And Centaur has gone to 100% for us settling in preparation for S2. Tank pressures are being increased as well. One minute to S2.
And 1 minute before the Centaur second stage ignites again. GOES will eventually be in a geosynchronous orbit, which is an orbit that keeps the satellite over a specific location on Earth. By maintaining a hovering position over a fixed point on Earth's surface, GOES are able to constantly monitor atmospheric conditions in a particular portion of Earth's atmosphere.
"30 seconds away from the Centaur second stage engine restart. Again, this is a burn known as MES2, main engine start 2, for the Centaur main engine. We'll hear the call from Marty Malinowski.
We have ignition and full thrust on the Aerotan. This burn is currently scheduled for a duration of 350.5 seconds.
And as you heard, we have a good main engine start, 2.
U has been enabled and currently commanding in oxidizer-rich condition. Chamber pressures, box pump discharge, and fuel venturi all look good.
This burn will last about 5 more minutes.
Hydrazine lines are at bottle temperatures at this point. Tank pressures look good. Storage bottles and batteries are as well. Centaur's current altitude is 112 miles, downrange distance 5,470 miles, current velocity 18,544 miles per hour. Continue to see our RCS thermal conditioning clearance. Signatures look good.
We are 24 minutes, 30 seconds into flight. The RL-10 engine continues to fire during its second of 3 burns.
Systems are performing as expected.
Three minutes remaining in this burn of the Centaur main engine.
EU continues to control near nominal, having worked off the excess oxidizer. RL-10 continues to look very good at this point in the burn. Two minutes remaining of this burn. All systems continue to look very good. Operating as expected. Burn altitude 132 miles. Downrange distance 6,291 miles. Velocity 20,954 miles per hour.
GOES has successfully traversed the Atlantic Ocean, and as you can see, is now making its way along the west coast of Africa. Continuing its ascent and its eastward trek to its final destination in space later this evening when it reaches its geosynchronous transfer orbit.
Seconds to MECO. RL-10 continues to look good. MR controlling near nominal. RCS line temperatures look good. We have MECO. Shutdown looks good. We have 4S settling.
And there is one more burn remains before NOAA's GOES separates. The third and final burn takes place after a nearly 3-hour coast phase.
So with the successful Centaur engine cutoff and the beginning of the long coast phase, we will now turn things back over to Tori. And later this evening, we'll be back here at Atlas Launch Control. Tori?
Thanks, guys. We'll see you after the coast phase. The GOES series features important technology upgrades and advancements. Blair Allen from NASA Edge is on set with NOAA's Jim Yo, Chief Administrative Officer for the Joint Center for Satellite Data Assimilation. Blair?
Thanks so much, Tori. Jim, first thing I got to ask you is, tell me, what did you think of the launch?
Well, this is my first launch live. It was really exciting, I got to say. But I'll tell you the truth, I'm even more excited about the work that's coming up for me and my colleagues putting these new data to work for better forecast and warnings for the American public.
Well, it's interesting because John Leslie, who works for NOAA, told us you were the weather satellite expert. So I imagine from your perspective, with all these new advancements, you have to be very excited about the things that you're going to be able to do now that when GOES becomes operational.
Absolutely. And of course, we started seeing some of the promise of this from GOES-R. We saw the benefits that we were hoping we would get from having the advancements from the advanced baseline imager with more channels, allowing it to differentiate more features in the atmosphere and on the ocean and land surface, from having better resolution that could help us, see the fine structure of storms and wildfires and any number of things like that, and finally having the rapid scanning that 5 times as often as the previous generation of GOES that help us see the evolution of storms. And give more timely warnings.
Well, okay, now speaking of that, just give us a sense. I mean, I know it's fast, but how fast are we talking when you think about being able to see something happening in the data on the satellite when it's really happening on the ground?
Right, it's almost instantaneous. In fact, this is really for near real-time warnings and information being passed to the public and to decision makers. We're actually able to scan small areas of the country, 2 of them from each of the GOES-R and GOES-S satellites simultaneously with a 1-minute resolution. So when you have something that's happening really fast, such as a developing storm system, you can focus in on that and be getting images every 1 minute. So you can see when cumulus clouds are piling up and overshooting the top. That's really an indication of a really strong thunderstorm with the potential for spawning really severe weather. We're able to see that in real time, know where that is, and give really effective warnings.
And just real quick, to understand that, the beauty with the GOES-R series actually is you don't have to remove the satellites. You just start focusing them on areas of interest, correct?
Exactly. I mean, you're able to scan an entire almost hemisphere from each of these, and what you do to do that rapid scanning is you just focus on part of that scan and refresh the whole disk, as we call it, more slowly. A neat thing coming up now, though, of course, is we'll have one centered over the eastern United States and one over the west, and this is going to give us coverage all the way from as far west as New Zealand, as far east as the western coast of Africa, up to Alaska and down to the tip of South America.
Which is absolutely perfect. It looks like GOES-S and GOES-R are giving us perfect coverage. Thanks so much, Jim. I really appreciate it.
My pleasure being here.
Tori, back to you, and tell Mike Curie he's got a ticket to ride.
Thanks, Blair. That was a great overall look at NOAA's GOES-R program and the ULA Atlas V rocket that lifted off with NOAA's GOES-S satellite just moments ago. We are now in the midst of the coast phase. When we come back, we will learn more about NOAA's GOES-S mission and check back in with Josh and Mike in Atlas Launch Control to take us through the remaining milestones, including spacecraft separation and solar array deploy. For now, let's take another look at today's launch.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES-S, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Atlas has begun a pitch and yaw maneuver to steer to its planned path, an azimuth of 100.7 degrees.
At 35 seconds, the rocket carrying GOES will reach Mach 1, traveling faster than the speed of sound.
Down, right on schedule. Signatures look good. Roll program is complete. The speed chamber pressures are rolling off as expected.
At 47 seconds after launch, the vehicle will pass through the area of maximum dynamic pressure, or max Q.
Max Q.
This is the point when mechanical stress on the rocket reaches its peak because of the rocket's velocity and the resistance created by the Earth's atmosphere.
Nine, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Atlas has begun a pitch and yaw maneuver to steer to its planned path, an azimuth of 100.7 degrees.
At 35 seconds, the rocket carrying GOES will reach Mach 1, traveling faster than the speed of sound.
Down, right on schedule. Signatures look good.